So I'm here to provide updates on the Independent Publisher Connector program. So for those of you who are not familiar with this, essentially this is a way to publish a custom connector to the Power Platform without actually having to own the API for which you're building the connector for. So these connectors, you don't have to actually download them. They're all certified by Microsoft and available within Power Apps, Power Automate, and even Azure Logic Apps, so beyond the Power Platform. No downloads necessary. As long as you have the premium license, you can access these. So just want to celebrate a couple of things today. We have 76 connectors in production, 4 new ones since we spoke last week. So we had AIHW, My Hospital's Connector by Paul, Emoji Hub by Troy, Infura Ethereum by Sebastian, who's going to be demoing today, and Word Cloud by TextFist, which is actually also by Troy Taylor. And of course, we have 37 outstanding publishers who have contributed by building a connector, collaborating with others, which we love to see when we see 2 people or more building a connector together, and everyone's here learning together. So it's awesome to see that. For the next Power Platform Integration Labs call, I think I briefly touched upon this last time, but I created an aka.ms link for you all to sign up if you're interested. The Power Platform Integration Labs call is basically people coming together to learn, ask, and build. So we are doing a lot of demos and conversational topics on connectors, gateways, data flows, essentially anything that has to do with integrations. The next call, which is the last Wednesday of this month, is going to be on, the main topic is going to be on triggers. So polling triggers, webhook triggers, so especially if this is something you're interested in, looking forward to having you all there. And in terms of the connectors in our pipeline, we have 42. Here are all of them here. We got a couple of new ones this week, including National Park Service. So that's definitely specific to the US, but it's awesome to see that. And we can now move on to the demo on Infura Ethereum. Sebastian, take it away.
That's cool. Thank you very much. Let me quickly share my screen and let me know if you see it.
Yes.
Brilliant. Okay, let's kick this off. Thank you very much. Good morning, good afternoon, good evening. So whatever time zone you have, I hope you do well. Thank you all for allowing me to quickly present my work on the Infura Ethereum Independent Publisher Connector. So that's quite a long name, so don't expect me to say it too often. My name is Sebastian, and I am a digital workplace architect for Swisscom in Switzerland, as the Swiss part of the company name obviously indicates. So if you haven't already, feel free to contact me on LinkedIn. I'm more than happy to get to know new people. So before we look into the connector, I briefly introduce the Ethereum blockchain and what's required to communicate with it. Also, we look at the challenges I have faced during the implementation of the custom connector and how I solved it. And then we go into a quick system demo and sum it up at the end. All right, let's do this. So what is the Ethereum blockchain? Ethereum is an open source blockchain-based distributed ledger. It is powered by software running on a network of computers or nodes that ensure data and programs, also called smart contracts, are replicated and run on all computers on the network without a central intermediary. So Ethereum can be used for sending and receiving cryptocurrencies and stablecoins, experience decentralized finance such as lending and borrowing, trade non-fungible tokens known as NFTs these days, and participate in online communities and decentralized autonomous organizations, in short, DAOs. So essentially, every node talks to many other nodes, and the API used in such a peer-to-peer distributed ledger world is different from what we Microsoft folks usually expect. It's not a RESTful API, which complicates matters a bit. So instead, JSON-RPC is used. And JSON-RPC is a stateless, lightweight protocol. It is transport agnostic in what the concept can be used over sockets, over HTTP or other ways. So, however, it is designed to be simple, but not necessarily intuitive as RESTful APIs and heavily relies on the documentation. As you may guess, that's not a perfect fit for a local platform such as the Power Platform with its generic connector approach. So also, if you want to build apps on top of the Ethereum blockchain, talking to a peer-to-peer network is not very practical. So for that, some cloud providers expose JSON-RPC endpoints of the network as a single public API on the web so that app developers can consume the network as a service. One of those services is Infura. Infura API provides instant access over HTTPS to the Ethereum network and therefore is a good entry point for traditional applications trying to communicate with the Ethereum blockchain. So this is also how I built the first version of my connector for Infura and the Ethereum blockchain. Due to the nature of JSON-RPC, there were some challenges I had to tackle since the Power Platform is very much focusing on RESTful APIs and open API-based services, and most of the UX relies on that fact as well. Unfortunately, JSON-RPC isn't made for that purpose, so we need to solve three unique challenges. First, JSON-RPC has only one endpoint and no path templates. While we still need dedicated actions in the platform for a good UX, we need to route every call to the same URL. Second, the method to invoke is identified through a post body and follows the documentation instead of a standardized approach. And the JSON-RPC parameters can be named or positional, and there is no exact pattern, so you need to decide on a per method basis. And third, everything in the Ethereum world is expressed as a byte string or a hex string. This is unusable for the average user, so the connector logic should convert from byte string to string or decimal values. So let's look at how we solve the problem in the connector by walking through a quick demo. And for that, I'm quickly switching to my other screen. Give me a second. Okay, can you see the platform flow?
Loaded looks great, yep.
Oh, brilliant. Okay, so just a quick proof that the connector is really showing up in the platform. So you really search for Infura, Ethereum independent publisher, and let's pick the get balance. That's just to check how much ETH I do have. Of course, you can use it as you know how it goes. You put in an Ethereum address, and with all of this, it's very simple. UX is straightforward. Of course, you can do something like sending yourself a daily balance sheet where you have your ETH balance, the current block in the connector or in the Ethereum blockchain block number, and also the gas price, for instance. So that's basically it. This is very much straightforward. Okay, let's quickly look at the connector in here. As I said before, we have to reroute everything to a single endpoint, and for that we can easily go for the routing policies. This routes the request to a single endpoint, and as you can see, there is an Infura project ID which is required to talk to the service as a connection parameter. So this is defined in the API properties JSON file. So when you create a connection to this connector, it asks you for the project ID, you enter it, and that's it. So every call is routed to this single endpoint. Now, the magic pops in when we talk about the custom code. And as I understood from Natalie, my connector is one of the first to use custom code as an independent publisher connector. And inside this connector, we do all the heavy lifting, so to say. So we check for the different operations. We do some conversion according to the documentation. We have some patterns to convert stuff from byte strings to normal strings or decimal values. And I think this is a good example on how to use custom code to do the heavy lifting inside the connector and provide the best UX possible. All right, so that's how I solved most of the challenges. Let's quickly look at what we can do now with the connector. So for instance, we could build like a MetaMask clone. MetaMask is a well-known wallet for the Ethereum ecosystem. We just add the Infura connector in here, the connection, So, and it shows up in here. And if I hit refresh, it should take a couple of seconds and until everything works. You can see I'm a really rich guy, roughly about $2. So it's not that much, but this is how you can talk to the Ethereum blockchain and, for instance, get your balance. Another use case, of course, is using it as a bot. So what's the current gas price? And I think you can guess the response. That should be the current gas price. That's basically how much a transaction on the Ethereum blockchain costs right now. While this is a bit fixed for the demo, this value really comes from the Infura endpoint and is real time. So basically, that's already it. So let me quickly jump back to the presentation. A quick summary of my learnings. So basically model any API as if it were RESTful, regardless if it is RESTful. So you have seen that for the JSON-RPC one. Then use custom code and transform policies to translate in between. When you are in doubt, I think UX should come over connector complexity. That's my personal opinion. And my personal learning is, bottom line, the Power Platform can talk to any API. This includes legacy or future systems such as the Ethereum blockchain. And there is one last disclaimer. The current version has a little bug in the deployment pipeline. Natalie and the team are on it. So please don't expect it to work right now, but it should work in the next couple of days. And that's it from my side. I hope it makes all sense for you guys. And yeah, I'm here for questions if there are any. Thank you.
Awesome, Sebastian and Natalie, both. Thank you very, very much. We'll let those questions trickle into the chat. But awesome, really, really cool stuff. And congratulations on being the first C# connector in there. That is very, very cool.
Thank you.